two very short ones that are features in the upcoming 1.17. First is fstrings, which has been in Python for a little while. Would you like a demo? I guess if there's anyone here who's not used fstrings before, I can give you some quick examples of why this is useful.
Yeah, I think a demo would be cool.
Yeah. Can you also talk about what's not?
Yeah.
What doesn't work? That'd be good. Yeah.
3. Okay. I will. And can you read that? Is that legible?
Yep. Yep. That's good.
Yep, it's good.
Okay, so I'm on a PyBoard 1.1 here. So the feature on its own is pretty basic. If I have as you know, a regular string, I can do string.format. So let's say a equals 22. The value is .format a, which is we've been using for a long time. And in Python 2, we can also use the say %d a to do the old % style substitution, printf style substitution. F strings are a new prefix on the front of the string before the literal, so f. And anytime I use the curly brackets, I can now reference variables from the current scope, and that includes locals, globals, and in fact any expression that Python can execute in the current context. So the value is a, and it other languages call this interpolation, and yeah, lots of other languages do this. Just like regular string.format, I can apply the same rules. So I can put it in 08x to make it a hexadecimal or whatever. And my personal favorite feature is that when I reference the variable, I can also do, so let's say I had a couple of variables, so b equals 7 and c equals 57, and I wanted to print them all out. I can write f results a, b, c, but I can also put the equal sign, special operator on the end of the variable name, and it automatically injects the expressions that produce those substitutions. So you can imagine previously you would have done results a equals b equals, and it's a bit of a pain. And what's neat about f strings is that I can change this to a plus b minus c, and this to sys.version, and this to let's just get rid of that and import sys. And yeah, I think that's pretty neat, and I've already started using it a lot in my own code. Sion asked, where does this not work? Okay, so in regular Python, if I go and get another terminal, Python. In regular Python, I can do some fairly complicated things, like I can write an f string which is hello world, but then inside the hello world, I can put a substitution, and I could do something like a plus b, which is a valid Python expression. Actually, that's not going to work. So it'll evaluate this expression a plus b, and then inject that into it. And in fact, this does work in MicroPython. But where this goes wrong is, what if I start doing things like putting curly brackets or backslashes and all that sort of stuff. So this works in Python, but in MicroPython, this will be a syntax error. Because unfortunately, in order to resolve this expression, we need to invoke the parser to figure out what the expression inside the quotes are. And MicroPython's we don't want to be calling the parser from the lexer. And so we limit it to not required to the expressions that don't require a full parse. The heuristics are pretty simple about matching closing braces and stuff. I hope that limitation doesn't affect too many people. I feel like if you're doing f-string substitutions where you've got such complicated expressions inside your thing, it's probably the time to use a variable. But yeah, if it is too painful, then I guess you can raise a bug and we'll investigate what the options are. But I should also highlight almost all of this work was done by somebody else. I just sort of tied up the pull request at the end and got it over the line. It's quite a clever way, the way this works, where while the parser is running, so let's say that's Python, in MicroPython, if I have a equals foo, then the lexer goes along and says, identify equals operator, and then it sees an open string and starts parsing the rest of the string until it sees the close quote. If I put the f on the front, it remembers it an f string, and then when it sees the open bracket with an expression inside it, so let's put it at the end, for example, a bar. I won't assign that to A. What it does is it temporarily it finds everything up until the closing bracket, stashes that in a temporary buffer, and then injects into the input stream, so as if it was the bytes that it was reading from the file or from the REPL or from the evaluation string, and actually turns this into, so it removes the characters from here, puts them in a buffer. When the string finishes, it adds .format A to the end. But as far as the lexer is concerned, those sort of characters were injected into the stream, and so it continued to parse as normal. It didn't have to, and it was as if the person had typed .format A. So this leads to another limitation, which is that if in regular Python, I can do f, I'll do A equals 22 and B equals 7, and I can write f A f B, oh, F equals is on there, and this works in Python because literal strings adjacent to each other are automatically concatenated, and this is quite a useful feature. It's the same in C. That works in MicroPython, but this will not work in MicroPython because you can imagine why. Behind the scenes, what this has become is .format A, .format B, and so we don't deal with that case. You could imagine we could detect this and inject a plus automatically, but I think the extra complexity is not worth it for quite an obscure use case. And we handle it, we don't generate something invalid. Actually, the one to watch out for is if you do this. This might cause some surprises because we do allow the literal to be prefixed on the front. Yeah. So what's happening here is it's producing the string. Producing the string as if you type that, and so be careful not to rely on literal concatenation when one of the sides is an f string. Yeah, cool. Any questions on that? Yeah, I should highlight again, this was really good work by Josh Clark, who sent the original PR.
Yeah, I think it's worth pointing out that it's not a third way to format strings, really. That it's just syntactic sugar for .format. I mean, you can see that here, the way that Jim's described it. But I think when I originally saw this, I'm like, oh, it's a third way to format strings. But when you play with it and you realize what's actually going on, as I said, it's just syntactic sugar, really good syntactic sugar for the original, for the .format. So I think that makes me a bit happier with it because it's it doesn't add that much, and the conceptual complexity is not high, I don't think, for this feature. It's really quite simple what's going on.
All right. Any questions on that?
Am I on? Can you guys hear me?
Yep.
Cool. One other thing I wanted to mention was, like, I've had real problems porting other libraries from like the CPython world to the MicroPython world, and this helps tremendously because there's a lot of like libraries out there that are using fstrings, and although there's always an obvious way to reformat them, it's a pretty large chunk of boilerplate. And the other big problem is that you can never push changes back up to the other library to make them MicroPython compatible. You've got to fork it and then create another library. So this is really exciting for me because there's at least 3 or 4 libraries that I've been stuck with maintaining my own because of this single feature. So yeah, yay is what I want to say.
I had one question, I guess. The status of the docs of those, limitations, as it were, and things like that for people. Because just from experience, the confusion it can lead to users can be really challenging if they're not really clearly documented.
Sorry, that's a really good point, and it's something that I think it's clearer when there are limitations in the libraries, but when the core language has parts that don't work the same way, because it's not like we say we don't support this method or something like that. You may be well aware of this already, but the way this works in MicroPython is we do attempt to document this stuff by having automatic tests that show differences to CPython. So there's tests at sleep_pydiff, and so for example, when I added the fstring feature, I added a test in that category, and so this is highlighting exactly those examples I just showed you where literal concatenation doesn't quite behave as expected. And so this code is run automatically during docs generation. And in fact, if we ever fix this bug, this part of the documentation will print out a message during compilation. And the result of this is that there's a page in the docs which is differences from CPython, and then this fstring is generated automatically. And people need to know that exists and that they can read this. I mean, if they do a web search, I guess, for the issue they're seeing, they might find this. And maybe if you're starting a new Python project, this might be a page that you find and would be useful for understanding if MicroPython is suitable for your project, or what the limitations are. But yeah, so we did add the three specific limitations are highlighted here as to what can be done. But as a general point, if you notice things like this in MicroPython, please either create the tests, the test cases yourself, or raise an issue, because they are really quite easy to create. And I think having these differences documented is really useful. And when I added this, I was really grateful that all this infrastructure already existed.
Cool, thanks.
The next one is really simple. So we've had support for NeoPixels in the ESP82.6 and ESP32 ports for a while. One thing, the feature is that we've now got that on STM32, and it's been done in a way that makes it possible to implement it a lot more straightforward on other ports as well. So there's already a pull request in the works for IMX, and we'll do it for NRF and RP2040 and others as well. I imagine you all know what NeoPixels look like. I guess the feature, because it was already supported on ESP32 and ESP86, we've kept the same API. So import NeoPixel, machine.pin.board.x8, for example, and I've got 32 of them. We've made fill a bit faster, and I don't know, you know what NeoPixels look like, right? Whilst I'm in. The reason this is interesting is that we've tried to build this in a way that's useful for sorry, I showed you my PyBoard while I was plugging in a NeoPixel and it rebooted. We've tried to build this in a way that's useful for supporting other types of bit streams. So the quirk about NeoPixels that's kind of frustrating about them is that the way you drive them is with a asynchronous serial protocol that is pulse timing based. You know, unlike the things that we're used to, like UART and SPI and I2C. And so almost no microcontrollers have a way to do that in hardware. And so what we end up maintaining is and there are heaps of libraries out there that do this for NeoPixels. So we end up maintaining libraries that that toggle a pin in exactly the right way. And so we've got a common way to do that in MicroPython now, and hopefully it'll be generic enough to support other other weird asynchronous protocols that come up in the future. Some examples might be things like, you know, infrared and so forth. So if I stop sharing, you can see my face has gone red. The NeoPixel turned on. Yeah, the main thing I want to highlight is that on ESP32 and ESP86 it'll work the same, but on STM32 we don't include the high-level module by default in the firmware, so you can just copy neopixel.py to your file system and it'll behave exactly the same way. And this is relevant to me, and the reason I was keen to spend time on it is because I've recently spent, well, recently is in small chunks over the last year, putting NeoPixel strips into my roof. So this is in my living room, and I got a Sparky to come and wire in the controllers and the boards. And so this is a nice way to add kind of like soft lighting throughout the room. And so I think there's 300 strips, 300 LEDs across 9 strips. My son helped me make the boards. But yeah, no, why not have 1,000, well, more than 1,000 NeoPixels in your living room? And I wanted to be able to control them with the PyBoard because it's nice and fast. And yeah, there you go.
Just quick math, is that 2,700 NeoPixels? Is that right? 9 strips, 300. Wow, yeah,
that would be right. Yeah. And yeah, that's more than I can do. The problem with NeoPixel as well is because you don't have hardware support, you can't use DMA, and so it's locking the processor a lot while it's running. So there's actually a couple of PyBoards running that across all of them. But I also plan to add, probably not upstream, but an easy library that you can use more memory, but the same way the TNC firmware does it. So you can use DMA.